Hello everyone, this is lecture 2 of AREC 333, Economics of Production and Resource Management. Last lecture we had a introduction of the whole course, what are the course formats and what are the course requirements. Today we're going to start with the first big part of this course, production function. This is the outline for today's lecture. We're going to focus on the technical aspect of production. When I say technical, which is compared with the economic aspects of production, which we're going to cover in later lectures. So first, we're going to talk about the production process. You can see here there are actually 3 components of the production process: the input, the output, and also the production technology, which transforms the input into output. And for the production technology, a very good description of that technology is actually production function. Once we know what is a production function, then we're going to talk about TPP, APP, and MPP. We probably only have time to cover TPP and APP, and I'm going to leave MPP for next lecture. This is suggested reading for today's lecture. Okay, so let's take a closer look at what are the components of a typical production process. You already saw this flowchart in last lecture. So production is a transformation of inputs into outputs. And during this process, it's very important to mention that the decision maker is the producer. A producer could be a firm, an individual, or a family who produces the outputs. On the right side of the flowchart is outputs, sometimes also called products or goods and services. Sometimes they only mention goods. But I'd like to emphasize here that services is also one type of output. In agricultural production, there's usually 2 types of outputs. For few crops, the examples are, for example, cotton, food, wheat, and so on. And for animal products, the output are usually milk, meat, fur, wool, and so on. On the left side of the flowchart is resources, which also have many names like factors of production or simply factors or inputs. I'm going to use those words interchangeably for this course, but I hope you remember when I say factors of production, it also means input. So factors of production or inputs are the productive items used to produce the goods and services. There are typically 4 different types of inputs: land, labor, capital, and management. Those there are 4 different letters which economists or production economists usually use to represent those 4 different types of inputs. L for labor, since labor already uses the letter L, and land will be represented by A, and capital K. The last one is management, which is M. In your Econ 101 or other economics course that you have taken, you probably already say that a production function is a function of K and L, and I hope you do realize what those 2 letters represent. So now let's take a closer look at those 4 different types of resources. Land is not just land, it also includes other natural and biological resources, and also probably like climate. L is human resources. Typically there are family labor or hired skilled labor. Capital include a lot of things. So basically it's manufactured resources. For example, buildings, machines, tools, agricultural chemicals, fuel, and so on. The last one is management. So that one, an example is the entrepreneur or the individual who use technology to combine other resources into outputs. So we need to differentiate here between management and labor. So labor, we said that it's those family labor or higher skill labor, but management here is more of the entrepreneurship. So different entrepreneurs might have different management skills, and the last component of the production process is production technology. Production technology is a description of the physical relationship between inputs on the left and outputs on the right. And you can see here inputs, I put the letters A, L, K, M there. So I do hope that you can remember what those are. I highlighted here that production technology is a description of the physical relationship, which means that the outputs are measured in physical rather than pecuniary or monetary terms. The examples here is that weight, when we say it's in physical terms, then it's bushels or pounds, but it's not in, has anything to do with dollar signs here. So keep in mind that production technology describes those physical relationships. And for this part of the course that we first gonna focus on physical relationship. And once we get to know the physical relationship well, then we will continue to the economic relationships. Now we know what inputs, outputs, and production technology are. Let's look at an example. So here I use the example of cereal production. Cereal is not the breakfast cereal that you're thinking about. It's, for example, the cereal that's for cereal crops that's for their grains. For example, wheat, barley, oats, and so on. So in the cereal production, the inputs are the fertilizer, seed, labor, machine, and so on. And the outputs here, there's two types of outputs: cereal, the grain, and the straw. So in our course, we are first gonna focus on one output case, and then later on, once we finish with one output, we will turn to multiple outputs. And last part is the production technology. So here the technology could include land cultivation, sowing, spraying, so on. Okay, we're almost there for production functions. As we mentioned in the last slide, that the production technology is a description of relationships between inputs and outputs. There are three ways of describing relationships between variables: table, figure, algebraic functions. And I'm gonna go over them all. First, the algebraic functions. I give an example here, y equal to 2x plus 1. This is a very simple function form. We call it a linear form because when you plot this function, you will get a straight line. Later on in this course, we will see more complicated function forms. And in this function, you also can say that there's only one independent variable here. So x, we call it the independent variable or explanatory variable, and y, we usually call it dependent variable. So later in this course, when we have, for example, multiple inputs, then on the right-hand side, there will be multiple independent variables. Okay, so let's use a more concrete example to illustrate how you can use different ways to describe a production relationship. Let's again use a cereal production, for example. Suppose that you're interested in the relationship between nitrogen here, which is an input for cereal production, and your output is cereal, and you measure it in terms of yield. And usually the production function is based on empirical observation. What I mean by that is that, for example, you have an experiment, and here, for example, there are 7 rows here, and you did an experiment. So you have your land divided into 7 plots, and for each plot you apply different levels of nitrogen, and then at the end of the year after harvest, then you keep a record of what the yield for each of those 7 plots. And when you get the data, for example, one of your plot might be the control plot, which means that you didn't apply nitrogen in that plot. Then you observe the yield is 15 units per hectare. It could be, for example, kilo or bushels or other units that you prefer. And then for 30 kilos of nitrogen, then you observe the yield is 25 units per hectare, and so on. So you put all those data that you collected from that 7 plots into a table, and it will look something like this. So by looking at the table, you kind of have an idea of the production relationship, how inputs are transformed into outputs. For example, here you might find that as you increase the nitrogen, for example, from 0 to 120, the yield is increasing. However, when you increase the nitrogen from 120 to 150, you observe that the yield didn't change, and you apply even more nitrogen, you observe that the yield actually decreased. So this, after you collect the data, put in table, you will have an idea. But having those data as a table is not enough to precisely describe the production relationship. Instead of using table where in the previous table there's only 2 columns, but if the numbers are not as nice as what we have used in the illustrative example, for example, there might be digits after there, or it's not a whole number, things like that, then simply looking at the table, you will not be able to find a very clear relationship between inputs and outputs. So one way of doing that is that, okay, we can put all those numbers into a figure or into a graph. So here, in this graph, the horizontal axis is the nitrogen in kilograms, and the vertical axis is the yield. And we use the data that we collected on those 7 plots and put them in this graph. And we can find that as again, the same as we increase the nitrogen from 0 to probably 120, and then we can say that the yield is increasing, and then after a certain point, the yield is actually decreasing when you apply more nitrogen. And another relationship that's probably not that obvious in the table is that when you observe that the first few points, you can see that when you increase nitrogen from 0 to 30 and from 30 to 60, you can actually say that the increase in output is increasing. For example, the yield increase from 30 to 60 nitrogen is actually more than the increase in yield from 0 to 30 kilos. And then you can see that that increasing rate in yield is actually decreasing and finally negative. So we can get a little bit of more information from graph, but again, using graph is not enough or not precise enough to describe the production relationship. One reason is that, for example, here we only have one input. If we have two inputs, then we can use a 3D graph to represent the production relationship. And I will show you guys 3D graphs later on in the course when we're dealing with two inputs. But by then you will find out that it's more, it's not that intuitive with a 3D graph. And we can use some techniques called isoquant curves. And that is also okay for representing production relationships with one output and two inputs. But what if you have 3 inputs or 4 inputs or 5 inputs? Then how are you gonna put that into a graph? So using graph is limited, and it certainly will help you understand when you have more inputs, but the imagination of human brain is limited, and we're living in a 3D world, and it's really difficult to imagine what a graph of 3 inputs. You will need a 4D graph. So we will have to use the algebraic functions to represent production relationships. Okay, finally we get to a production function. The third way of describing the production relationship is using a production function. Let me first define what is the production function. It's the maximum amount of output that can be produced with a given amount of inputs. I'm gonna explain in a little bit why I emphasize maximum here. But let's first, again, looking at the example, which is the wheat production. So suppose you have a production relationship y equals fx, and here y could be the wheat yield in kilogram or in bushels, and x is actually the input. It could be fertilizer, for example, nitrogen. It could be labor or something else that you're interested. And the F here is the mathematical relationship between inputs and outputs. Okay, so what do I mean that the production function is the maximum amount of output that can be produced? For example, let's take x equals to 90 here. And for 90, I remember that it's 70. Okay, so the output is 70 here. So this is the maximum output that all producers can produce, or you may say that this is the output that the efficient producers can produce. But for example, here at this point, let's say using 90 kilogram of nitrogen, can a producer produce 50? Of course, yes. The producer could simply use here this amount. Let's say maybe this is 70. The producer could simply use 70 kilo of nitrogen and then produce the 50 yields, and then just dispose those 20 kilograms of nitrogen. So again, the production function is describing the relationship of the maximum output or the output of the efficient producers. So all of those points on this curve are the maximum output, and any output that's below this curve the producers can also produce those outputs, but that's not what the production function is describing. Okay, before I can give you specific algebraic functions to represent production relationships, we first need to define what's fixed inputs and what are variable inputs. So fixed inputs are those inputs whose quantity does not vary with the level of output. So for example, in the nitrogen production example, we assume that we had experiments on 7 plots. On each of those plots, the quantity of the land actually didn't change. So that is a fixed input. However, the nitrogen, when we change the level of nitrogen, then the output change, and nitrogen in that example is the variable input. So whether an input is fixed or variable, it depends, right? So it depends on the length of time. And I think you must have heard of this term short run or long run in your Econ 101, but let's give the introduction again to make sure that you still remember. Usually the difference between immediate short and long runs are in time, but that's not always the case, and I do hope that you can realize that. Immediate run is the run where all the inputs available to a producer are fixed and they cannot be changed. An example here is that close to harvest. For example, if you're growing wheat, then immediately before harvest, none of the inputs can be changed. And probably you can argue that you can still change the input of labor, but in terms of land, nitrogen, those inputs you cannot change. Short run is a time span during which some inputs are fixed and some inputs are available. So it's a mix of both. The example here will be 3 months prior harvest. The labor will be variable, the land is fixed, and the nitrogen is probably also fixed because you have already finished applying the fertilizers. In the long run, it's the other extreme where all the inputs are variable, no inputs are fixed. So the other extreme is immediate run. All the inputs are fixed, nothing is variable. So you must have already learned the long run in your Econ 101 in terms of cost curves, average total curve, stuff like that. So here I want to emphasize again that the difference between immediate short and long run are not just on time. For example, the long run of the lemonade business is very short. So that is an example showing that the difference between those 3 runs are not only on time. It's usually on time, but again, the difference is depending on whether the inputs are variable or fixed, or if it's a mix of them. So all variable is in long run, mix of them in short run, and all of the inputs are fixed, that's the immediate run. In this course, we are focusing on short run and long run, and the immediate run here, I'm just giving you an idea of what that is. Okay, so now we understand what are the long runs and what are the short runs and the immediate runs. We can finally define the production function. And the definition of the production function actually depends whether it's a long run production function or a short one. Here, let's first look at the long run production function. This is the algebraic function, and I first wrote it as y equals f. F means the mathematical relationship, and f is a function of capital, labor, management, and land. So we are using those 4 letters to represent different inputs, or to put it more abstract, we can just write y as a function of your of x1, x2, ... until xn. So in this function, we assume there's n inputs. So again, y here, it could be yield, or it could be other outputs. And x, I emphasize here, it's variable inputs, because in the long run, all inputs are variable. And examples here could be fertilizer, labor, land, and so on. And f is the mathematical relationship. And you will soon find out what is the difference between the long run production function and the short one. We wrote the short run production function slightly different from the long run one. So here, instead of having all of the inputs variable, which is a long run case, here in the short run, some of them are variable and some of them are fixed, and we need to differentiate between them. So in terms of the production function, we put the variables on the left of that vertical line, so which is x1, x2 until xs. There are s variable inputs in this function, and then on the right of that vertical line we usually read as conditional on. So conditional on x, s plus 1 until xn, those are the fixed inputs. To make our life easier, let's start with 1 variable input and 1 variable output production function. So this is obviously a short run production function where s equal to 1. So all of the other inputs are fixed. And if there's only 1 variable input, then in the production function, we will have y equals to fx1 conditional on from x2 to until xn. And that's probably still a little bit too abstract, but how about we changing x1 to k, and k is capital here. Then the short run production function will be y equals to fk conditional on lam. Output is a function of capital, which is variable, and then conditional on other fixed inputs, including land, labor, and management. So here I like to introduce to you guys an economic term called ceteris paribus, which means holding everything else constant, and it's relevant to this short run, 1 variable input short run production function. So for example, in the first equation, y equals to fx1 conditional on those stuff, we are actually having a case of holding x2 until xn constant. So you can say that y, for example, yield as a function of nitrogen, and then after that you can say ceteris paribus, so which means that all of the rest are constant. This is a very frequently used economic term, and I do hope that after you take this course, you are able to say this. It might sound professional. And for the sake of notational convenience, from now on, I will just skip the part after conditional. For example, the first function y equals to fx1 conditional on x2 stuff, then I'm just gonna write it as y equals to fx. Oh, sorry, that should be y equals to fx1. So you know that this is a short run production function and x1 is variable, and it's just for notational convenience. There's no other reason. Okay, now so we have our one variable input, one output production function defined, and I should emphasize again, one variable input, one output short run production function defined, and we're going to use this production function to illustrate the concepts of TPP, APP, and MPP. So for today, I will cover TPP and APP, and then leave MPP for next lecture. The first concept is TPP, which means total physical product. So what is TPP? For the one variable input short run production function, TPP is simply the y in that function. So it's the output. And again, we need to be careful that physical here means that it's not monetary and it's not economical, or it's not about value. So it's only about those physical product. TPP can be used to illustrate technological change. What is that? So it simply means there's a great level of output for the same level of input. So it means that TPP change from TPP 0 to TPP 1. So how does that look like? For example, this is your TPP 0, and you could have another TPP. This is TPP 1. So when a technology change happened, your TPP changed from 0 to 1. And for every level of input, you get a greater level of outputs. The examples of technological change include, for example, there's better variety so that you get higher yields, or in animals that could be selective breeding, or it could be biotechnology. For example, the BT variety is now for corn or soybean, it has much higher yield. APP different from TPP in just the first word. So TPP is total physical product and APP is average physical product. It is defined as the average productivity of each unit of variable input used. A lot of times you hear from news or read in papers saying that the productivity of something, and usually that's APP. So in terms of mathematical functions, APP is defined. Here you see new notation with 3 horizontal lines. That means defined. So APP is defined as TPP divided by X, which is also equal to Y over X. If we're writing Y as a function of X and use Y to represent the output, X to represent the input. We also sometimes write Y as a function of X. So fx, and if you say those 3 different notations, it's all used to describe APP. Let's use an example to explain how you calculate APP. Actually, let's start with the simplest example where you have a linear production function. Here I use y equal to 2x as an example. And remember, let me first write down how we calculate APP. So APP is equal to y over x. And if we have the production function of y equal to 2x, you can actually calculate that APP is equal to 2 everywhere. So in terms of geometry, we can find that, for example, take this point as an example. This is its y value of that example. And here is the x value. So APP is simply y over x. And if you take another point here, let's take a different point of x equals to 4. And you can actually find that here, its APP is, let's call it y prime, and its x is x prime. So you can actually find that its APP is equal to 8 over 4. It's again 2. So if you take any point on this linear function, you will find that APP equals to 2. That is just a property of the linear production function. What if we have a nonlinear function? So here I use the neoclassical production function as an example. For example, suppose y equals to 6x squared minus x cubed is a production function. Then how can we get the APP? We can actually calculate the APP is equal to y over x again, and 6x squared minus x cubed divided by x. And you can find that APP is 6x minus x squared. So here you can find that if you use a algebraic function, then it is really easy to get your APP. So let me write it down here. APP equals to 6x minus x squared. And if you need to find it on a graph, and if your production function is nonlinear like it here, then you will find that it's not so easy to find because the APP is different at point. So again, let's take these points first. We know that the APP is y over the x value here. And this, if you still remember from your high school math knowledge, y over x is actually the slope of this blue line here, of this line here. So this is actually called a ray line. It starts from the origin O and then connected to a point on the function. So the APP at that point is the slope of the ray line at that point. And if we have to calculate the APP for a different point, then we have to, for example, point A, we have to connect, excuse me, this should be a straight line. We have to connect OA, and then again, the APP should be the slope of the ray line OA. Let me put it a little bit better. So here I have 3 points, A, B, and C. You can make a guess which one has the largest APP. And I'm actually going to use a animation graph software to show you how to get APP and to illustrate the difference between a linear and nonlinear function and what is its APP curve like. Okay, so let me show you on the graph how the APP is like for a linear function. The software or the website that I'm using is called GeoGebra.org. And I highly recommend if you're interested in plotting graphs. So the function is y equals to 2x. You can see, and I have a point here. If I move along this, you can actually say that the ratio of y over x doesn't change. And let me actually put a point here to represent the APP at different points. And you can say that the APP is always 2 at different points. And we can actually plot the APP curve for linear function, and you can say that is a straight line.
Let's say the simulation for the nonlinear case. Again, this is done in GeoGebra, and I will upload the GeoGebra file on A-class. You can actually go to geogebra.org and then create an account, and with the file that I shared, you are actually be able to say how the simulation works and try it yourself. I hope that will help you understand the concept better. So again, here x is a point on the production function, and you can see that there's a ray line connecting the origin O and the point X. So the APP is actually measured by the ratio of the segment XS divided by segment OS. And you can see in the nonlinear case, as we move X, the ratio of XS over OS is actually changing. Another way to check that this ratio, which is the value of APP, is changing, is remember something that you learned from your high school math is a trig function. Imagine that the angle between the segment OX and OS is alpha. Let me actually put alpha here. So imagine that angle is alpha, and then you will realize that APP, which is equal to XS over OS, is tangent alpha. And you should be able to see here that as I move X along the curve, the angle is changing. And at this point, you can guess at the 3 points A, B, and C, which one has the largest APP. So pay attention to the alpha value, and you will see that at point B, the alpha value is the largest, which means that the APP value is the largest. And as I move from B to C, you can see that the alpha value is decreasing, which also means that the APP value is decreasing. So let me put this alpha away and actually show you how the APP curve looks like as I move this point X. So let me move it. Pay attention to the blue point, which is the APP value. And this time you probably can say that APP is changing all the time. And let me actually add the APP curve here, which is if we use the production function y over x, we can get the value is 6x minus x square. And then this time pay attention to when I move x, you can see that the APP value is changing along the APP curve, and you should be able to say that when x is at point B, APP value is actually the largest. And then as you move along the curve, APP value is changing. The 3 points A, B, and C are special for the new classical production function. And as later on you will say that one of the point has the largest APP, one of the point has largest TPP, and one of the point has largest MPP. So we know here point B has largest APP. And if you still remember what is TPP, TPP is just the total physical product, and it's the value of Y. So we can say that at point C, this TPP is largest. And now since we haven't introduced MPP, but once we introduce MPP, and it will be more clear that at this point C, MPP is actually equal to 0. We will get there. But again, try this animation yourself, drag the X point as you like. And I do hope this will help you understand the concept of APP better.
So today we introduced the components of a typical production process, the inputs, the outputs, and also production technology, which transforms the input into outputs. And I showed you guys how, or the different ways of describing production technology. You can use a table, you can use builder, graph, or you can use the algebraic function. And we also covered the APP and TPP of the production function, which are the technical aspects of the production function. So nothing here is economic yet. And I do hope that you enjoy this lecture. In next lecture, we are going to focus we are going to focus on MPP, which is one of the most important concepts of this course. And feel free to leave any comments that you have on eClass, and if there's any suggestions that I can improve your learning experience, let me know. And you can find on eClass that there's a forum there with you can leave your comments without being identified. So really feel free to leave any comments that you have, and I appreciate that.